So, guys, if you remember, in the last class, we were going through the formal introduction about the badge, and we discussed a bit on the VPN technology. So, the reading material is over on the Google Doc. Basically, this document you will, of course, find it across on our class zero when you go to learn network journey.
So I'm already in the hotel where it is.
Yeah, and I have to upload it, but you will find it in this location after the class. Okay.
Oh,
Yeah. So somewhere where it says SVPN under class zero, you will find the G Drive link and you can download the reading material. So I'll upload today after the class and you can find it out. Okay. So I'll just recap on whatsoever we did so far in this. So we discussed about the exam pattern for both CCIE Sec and the SVPN. I have told you it's a MCQ based question. This is a consists of two paper, which is a written paper plus DOO, which stands for lab 8 hours, and this is a MCQ. All the required links are being kept here for your reference. You can go back and check the followed up links. You can see the hardware list. You can see the changes that been introduced in 6.1. Okay, all the needful things. This was the technology topic that we started with. So we talked about the types of VPN. We started with the types of VPN. So we discussed about on the basis of the tunneling protocol, level of security, implementation, access requirement, use case, network architecture, and based on the technology.
Uh, Sorry, I did not get you first. Hello?
Yeah, go ahead.
I did not get you what you said actually.
What I said in the sense, you joined late or
A bit late, maybe when it got started actually. I don't know. Just now I joined.
see what I was telling is I'm revising what was done yesterday.
Okay. Got it.
Okay, so these are the topic that we discussed in the day one. So after discussing about the VPN classification, we discussed about VPN classification based on oversight layer. So this is the reading material for that. Then we discussed about the popular types of VPN, which includes remote access, site-to-site, IPsec, SSL, MPLS, Open VPN, DM VPN, Flex VPN. So the notes you can find it over here. Then we discussed about the CIA model, confidentiality, integrity, availability.
It's availability or authenticity?
It is availability.
No, but someone said me authenticity. It was related to the AES and DES and all that encryption. Maybe they are wrong.
AES-DS is for the encryption, symmetric encryption.
Okay.
Okay, and the digital certificate RSA we discussed in the asymmetric, and MD5 SHA is for the integrity.
Okay. Go ahead, please.
Okay, and then we discussed about the site-to-site VPN concept in a overview. So here in this overview, we discussed about the parameters that's required in the phase one. Then we discussed the parameter that is required in phase two, IPsec phase. Okay, and this is something which we will be talking of today. So today's class is more on the IK, the key management topic. So we'll discuss about the different steps that's involved in the IK process. Okay, so in the last class, we went with an overview site to site. We discussed that there is a phase one. We discussed there is a phase two parameter. Phase one is a IKE protocol which is taking care of. There's a key management. This is where the IPsec negotiation happens. IKE are of two types, version 1 and version 2. Version 1 has two types. One is called the main mode and the second one is called the aggressive mode. So this comprises of 6 messages. This comprises of let's say 4 messages. Whereas in the V2, it's a simple 3 message only.
This main mode and the second one is which mode?
Aggressive.
Aggressive.
Okay, and so on. Here also we have the certain messages. So we will see that in today's class. So the notes are already there for your reference. You can go back and read it. I have put some needful diagrams also so that you can always refer it. So this is difference between main mode and aggressive mode. This is a quick mode which has 3 messages, QM1, QM2, QM3. This is difference between IK version 1 and 2. This is difference in terms of graphical representation. Okay, so today we will see more about the IK versions. IK version 1, the messages that happens flow in the IK version, and what happens in IPsec. In the next class, then I will discuss about cryptography. Then I'll discuss about more in depth from the IPsec point where we have those transport versus tunnel, the headers of it. Okay, all those things we'll discuss in the next class. So today we will discuss about IKE.
Can I ask one question regarding?
Yeah, go ahead.
See, in IKV version 1, the first phase 1, we are using ISAKMP, right?
Yes, correct.
So ISAKMP is included in the IKV 1. How?
No,
ISAKMP is...
ICKMP is an old name. The new name is IKE version 1.
Oh, okay.
It's the same thing. It's the same thing only. It's not the other way. Okay.
Okay.
So, do you guys know over on which protocol or which transport layer does the phase 1 happen?
I think UDP 500, right?
Yes, correct. So it happens
500 and 4500 as well, I think.
Yes, correct. So it happens on 2, depending upon what vendor you're using. So let's say if this is a branch A, this is branch B. So it will happen over on UDP 500. Okay. So if you see the port number register, say this is a ICKMP IK, which is yes to the UDP. Yes for the UDP. And when you search for 4500, it is again a UDP packet, which is for IPsec NAT transfer service. So it's when your VPN termination is happening on a device which is behind a NAT enabled devices. So in that case, we use this. Okay, so coming to the IK now. So IK is the main fundamental here. So it's called as Internet Key Exchange. Okay, it's a protocol which is used to do the initial exchange of the security association. So security association is nothing but all that parameter protocols that we are utilizing or using in terms of bringing up the phase 1 and phase 2. So what this consists of, the IKE is used for key management. It is used for the SA establishment. It is used for authentication. Okay, and as I told you, the key exchange process. So we are making use of the DH groups, which is a asymmetric based key exchange process. So asymmetric means there will be a public key and a private key. Whereas if you come across a word called symmetric, that means there is only a single key in order to transfer them. Okay, so DH follows a asymmetric order. So IKE is responsible for all this: key management, SA establishment, authentication, and key exchange. What are the two different types of IKE? You might have heard so far, you might be going with version 1. But IKE is actually two types, IKE 1 and IKE version 2. By default, you might still be using this in most of IPsec, but this offers a better and advanced algorithm supports. It has the dead peer keep alive inbuilt. It has inbuilt support to NAT-T transversal. So a lot of things are being available this. So if I put down in a tabular format, so this was documented under RFC 198 and this was 2409 and it was first been patented in the year 1994. You know that this has two different modes.
1998 or 4?
Sorry, come again?
It's it 1994, right? 4 or 8?
98.
Okay.
Okay. So two modes. One is main mode, which has 6 messages to exchange. Then the aggressive mode, which has 3 message. Okay. So either one, by default, this is enabled. There is no inbuilt keep alive. Okay, and it supports both symmetric and asymmetric key exchange process. Coming to the version 2, which is the latest version. So the RFC that has been patented 7296 in the year 2014. So let me write the IK version 2 over here. So it do not have the concept of main mode and aggressive mode. Instead, it has 4 messages: IKE SA init, IKE authentication, and a child SA. Okay, so these are the few messages that is supported here. and it includes inbuilt support for the keep alives. It also supports the NAT-T transversal, and it has support for the advanced encryption and algorithms. So some algorithms and some cryptographic suites have been updated now. So it supports even them. That depends completely on your vendor now. Not required that the vendor has that advanced algorithm. So if you're still using ASA or any traditional one, then you have to still be using the regular one like a SHA or let's say the PSK values, etc. But there are the advancement happened in the cryptographic, which IKE version 2 supports. So these are the two types, version 1, version 2. By default, version 1 is enabled. You can, of course, change it to version 2. If you know about one of the popular type, Flex VPN, which is the simplest way to configure the IKE version 2. But if you go with a site-to-site VPNs, by default, the IKE V1 get considered. And if you want to make use of V2, then you have to do certain changes while configuration, and then you can configure it over on a site-to-site as well. So this is the type. Coming to the terminologies.
Sagar, this IK2, does it provide any extra security?
Yes, it has, because it is supporting the advanced cryptographic, which is above the SHA 512, above the above the regular ones. So definitely the security is also more in this.
So for the going forward, it's advised to be used that IKV2 always.
Yes, correct. V2 is the latest one. Like how we upgraded from, let's say, HSRP version 2 to version 3, or sometimes we have upgraded from SNMP V2C to V3. So similar way, version 1 is also getting obsolete now. There are enterprise which are using V1 because it has that shaft till 512, but certain enterprise need much more or advanced support. So in that case, V2 is the solution.
Does it has a dependability on that hardware capability as well?
No, nothing
Like
on the
particularly only hardwares like
It will be
ASA
software
models can
basis
support.
only.
Sorry.
It will be software basis only.
Mhm.
That particular software, whether it has that advanced suit or not, cryptographic.
And Sagar, you are talking about the Flex VPN. What is actually the Flex VPN? Why we use?
That we will come. Okay, it's a one type of VPN, like how we have DM VPN, hub and spoke, we have site to site, we have SSL. So similar way, we have some more like Flex VPN. It's a new introduction into the VPN category.
Okay,
I can say that it's the simplest way to configure your site-to-site VPN without much hassle, without thinking about this cryptographic suite or this algorithm. It's very straightforward in Flex VPN.
Okay, this topic is related to the site-to-site VPN, no? This IPsec
Yes,
channel.
that's a type of site-to-site only.
Okay, got it. Thank you.
You were mentioning some about child SA support, right? What it means actually?
These are the messages.
So the third message is create child SA.
That is where the data is being transferred.
Okay.
Okay. Whereas in the first two, it is about the initiator and responder parameter negotiating. When the two steps happen, then finally the data will start transmitting. We'll come to this. I have a picturized to show that.
Okay.
Okay. Now, in terms of terminology, this is something which we would be regularly using it. So I want to put it down in the beginning itself. security association, in short form SA. Now, this comprises of all that cryptographic algorithms, mode, encryption key, parameters that we need for the data to be passed upon on the tunnel. Okay, so I can say that it's a combination of all cryptographic algorithms. Then comes the encryption keys. So it's a collection, I can say. Sometimes what happens, if you get a suggestion, check your security association. So it's something to deal with those algorithm and those integrity values that you might have set. So they are asking you to check this. Even when you do the debug, sometimes what happen is debug message show you that security association mismatch. So don't get confused. It's not a new terminology. Instead, it's to do with your algorithms or encryption. So you have to go and check those in the phase 1 and phase 2, whatever you have been uh, assigned to them. Okay, now when we talk about UDP 500, UDP 4500, the first packet in the message one, when I show you the graph, there will be something called vendor ID, which is written as VID. Okay. So if I show you one of the graph, so if you just expand this main mode, you will see something for VID. There is a VID in the aggressive mode as well. So along with security association in the MM1, we are also sending something for VID. So VID stands for uh, vendor ID. So vendor ID is important to be mentioned in the messages, because this is where it will support the information about NAT-T, dead peer detection feature, fragmentation. So this is something we write it in the vendor ID. Okay, so the term vendor ID comes in IKE. Then there is something called nouns, whatever you can call. It's a randomly generated unique key. Randomly generated unique key. The purpose of this nouns is it always remains unique. That means if you has generated something on the message 1, the next message will not reuse the same randomly generated key here. It will be always another key for this. So this is again from the security concept, and this is also part of your messages. So if I show you in this case, you can see the nouns. So basically nouns is some sort of a random generated keys, or you can say random generated is sequence, just to show that it's belonging to this parameter, and this always remain change. If you have the next message 3 coming or next message 4 coming, it will have a different nouns. So it's a unique identifier that we see in the messages. See, this is what is, say for example, in the message 1, you can see that the message 1, when you initialize, there was a randomly generated sequence, and the responder was unknown at that time. But in the next messages, what it does, it has to show that that's the initiator which is retained, and it will generate a new sequence while it is sending, while the responder is sending. See, this is what. So you can see there is a randomly generated sequence. And from the graph as well, if you see here, there is a nouns added up here. Okay, we don't troubleshoot, or we don't have any involvement here because this is randomly generated and it is passed upon with the messages. But it's something which we repeatedly use in the terminology. Then comes the identity initiator and responder. Initiator or identity responder, which we write it as IDI or IDR. Okay, as the name says, when the initiator is initiating, it will have a sort of identifier to that, and when the responder is responding, it is gonna have a responder key to that. So where does it come? Let me show you. So if you see here in the main mode, you can see the IDI added up here. So this is the identity initiator, IDI. At the same time, when the responder was responding, the IDR is being added in the message 5 and message 6. So if I open Wireshark of message 5 and 6, so this is 3 and 4. This is for 6. So you can see the IDI, IDR.
IDI means vendor ID. This is vendor ID.
No, nothing to do with vendor ID. It is a representation of who is initiator and who is a responder.
Okay.
Then we discuss something about DH group, which is DeFi-Hellman. So you know that this is the key exchange method, which is using a asymmetric method. Okay, asymmetric key exchange method. So there would be a public key, concept of public and private key. Okay, there is a flow which I'll show you some when I'm taking a topic for DeFi-Hellman. We'll talk about something called Rob and LS, and we'll talk about how the keys are exchanged between the two persons. So it's a nice topic, nice concept to understand how the keys are exchanged. So this is what is included in the IKE, that is phase 1, in order to exchange the key. And yeah, these are some terminologies which you should know. Apart from this, most of them would be repetitive that we would talk AM, MM, let's say QM comes in the IP side. That is phase 2. Okay, so something which is frequently or which is very rarely used, I have put up here. Something which we are already aware, encryption, algorithm, lifetimer, I have not kept here because that is something which we are writing or we are deciding. But these are something which sometimes occurs automatically, like nouns, vendor ID. These are not into our control. It comes auto-generated. Okay. All right. So now we will get into the modes. So we already discussed, but we will discuss from the picturized format. So what happens in MM and what happens in AM. So let me take you to the picturized format. So if you see this graph, let's say this is initiator and this is responder. Okay, let's say branch B and branch A. We know that aggressive mode consists of two round method, which basically are 3 messages. Okay, message 1, message 2, message 3, or you can call it as AM1, AM2, and AM3. And within this AM1, 2, 3, the first message is considered to be unencrypted and unauthenticated, because that's the first message when it is initiating the packet. So when it is initiating the message, it has security association. This is key exchange, nouns, initiator identifier, and the vendor ID. These are the information which is all together clubbed and sent in a AM1 message. What AM2 does, now it has already received that nouns, so it will keep that nouns, it will maintain that nouns received from the initiator, plus it will add its own nouns now, and also it will put all its parameter. It will add its security association, key exchange, vendor ID, initiator identifier for responder, and the authentication parameters. Now, if you see this, this is unencrypted, but responder is authenticated. That is because it has found a nouns, it will add its nouns, and it is a unencrypted, but it is authenticated. What was the first scenario? It was unencrypted and unauthenticated. Now, since it has received and it is maintaining that nouns of that initiator, now it is unencrypted because still the phase has not come up, but it is at least authenticated. So this happened just in 2 messages. And in the final messages, you can see that it is encrypted, but it is unauthenticated. Okay, and in the third message, what happens? It is going to prove that initiator is the actual person. So by sending the AM3 message. And after the completion of 3 message, we expect it is encrypted and authenticated. So it takes only 3 messages to come up with the phase 1. Okay, and the things are put up here: AM1, AM2, AM3. If you compare the AM with the main mode, you can see the difference over here. In the AM1, we sent all the parameters in AM1, but the same thing don't happen in MM1. That is the main mode. In the main mode, we only keep the security association and vendor ID. We expect the same coming from MM2, that is responder. Then in the MM3, we will send the nouns and the key exchange and the vendor ID. Then we expect that coming from MM4. So you see it's 1, 2, 3, 4. 4 packets done, which in the other case, we did it in 2 packets. And finally, we have that final PSK check, which is the 5th message and 6th message. So in this, we are sending up all the authentication or certificate or whatsoever to prove the actual identity. And then after completion of the MM6, we expect the phase 1 is up. So this is what the difference between the two. If you need a quick VPN with less security, then you can go with this. It can also be little complex during the debug process because you are sending a lot of things. If you are stuck at the debug, it will be a problematic for you to understand which parameter is having a problem. Whereas this is for someone who is okay with a slow processing or slow buildup of a VPN, but it's at least a high security. And it's a bit easier to debug because if you're stuck at certain message, you can easily go to that particular parameter and make the changes. So that is what the difference is between AM and the main mode. And if we talk about main mode from the message perspective, then this is something which you have to remember during the debug of your VPN establishment. So when you do run a debug, if you come across, let's say message 2 is stuck or it is failing at this. So what is it carrying in that first 2 messages? So you should know this particular chart. So it could be something to do with encryption, could be hash, could be DH value. So this is what is sent in the first 2 messages. In the next 2 messages, we are sending the hash value of the PSK, not the exact key, but the hash value of it. So if you are stuck at somewhere message 4 or message 5, then it is to do something with, let's say, the value behind the hash value of a PSK. You can once check the integrity algorithms. You can see the parameters is good or bad. And if it is failing at message message 5 and 6, then it is to do something with the actual key that you might have set. If you have set, let's say, Cisco 1 and you set Cisco 2, this is where most of the time you're stuck at message 5 and 6. Okay, so it will check if the PSK is matching or not in the 5th and 6th. Now, why those 5 and 6? That depends who initiated it. If you initiated over here and if you check the log messages for show crypto ICKMP, you might end up with message 5. At the same time, if you check over on this, then you will see the message stuck at 6. So 5 and 6 are correlated. It's just that on which device are you triggering that show command. So this is where that will help you. This is something which this graph will always help you to troubleshoot that phase 1 problems. And if you try to see from the packet level, the first message, which is an initiator sent, is generating a random nouns. It is keeping a responder to be 0 because it is not aware of it. It's maintaining the security association. It is maintaining the vendor ID and it is pushing it out over on the UDP 500. So that is what the Wireshark says. So source port 500, destination port 500. Now, intermediately, if you have some firewalls which is blocking the UDP 500, then make sure you allow UDP 500 in that. Otherwise, you're stuck. Okay. And this is what the message, this is how the Wireshark capture for message 1 would look like. Straightforward. You have a UDP layer and you have the Internet Security Association, which is ICMP header on that. You can see the initiator SPI, responder SPI set to be 0, and the payload security association, which is nothing but collections of all your algorithms and encryption keys, etc. In the message 2, which is the response back for message 1, you can expect the same thing, but it is going to retain what was being received by it. So it is going to maintain that initiator, but it is going to add its random generated for that particular session, and it will also announce its SA and its vendor ID, and it is going to be sent. So it's a unencrypted and unauthenticated as of now. And if you see the Wireshark capture, it's once again over on 500. You have this from the previous capture. You can see that this ends at 6BDFD, and that was nothing but from the previous scenario, 6BDFT, which is nothing but it has maintained the same thing, but now it has kept its own randomly generated nouns for this session, and along with it security association. If this 2 matches up, if the matching happen, you're good with 1 and 2, and now it's time for message 3 and 4. Now the initiator will send message 3, and while it sends message 3, the message 4 comes from the responder, and once again the parameter are checked. So in this condition, in this message 3 and 4, you can see what are the things that's been shared. So you have a nouns, you have a key exchange, you have a vendor ID. Okay, and this is again unencrypted, unauthenticated process. And the secret key exchange happens over on the DH value. In the 5 and 6, that happens when the 3 and 4 has done. If you're stuck, then you have to once check for the respective things. If there is all good, you go to the 5th and 6th. And in the 5th and 6th, so you can see the actual PSK, the shared secret hash value, or if it's a signature based, the digital signatures or the certificates that we call. So if it is based out of that, then there is where it has to be authenticated. So now you see, once the phase 1 is completed, it's an encrypted and authenticated process. Okay, and at this point, your phase 1 would be shown up as completed. Yeah, so that is about AM and QM, AM and MM. So any doubt so far?
So when we configure the status at VPN and it will work on phase 1, do we need to define that what we're going to use, MM or AM? When do we define that?
We don't define that, because by default IK V1 will take main mode only.
Okay.
So you will end up seeing MM messages by default. If you need it AM, then you have to do the specific CLI config to tell the negotiation happening over AM method.
We need to do through CLI or we need to do through the GUI mode?
It depends again. If you have a device like ASA, you can do completely over CLI. You can also make use of ASDM to do this. So it is again up to what access you have it on the device.
If two sides are Palo Alto means, then we need to do through GUI.
Yes, correct. If it is Palo Alto, then definitely the graphical will be much simpler.
Okay, if one Palo Alto, one ASA means in the Palo Alto side we need to do through GUI, and then we need to come to the ASA and we need to do with CLI type.
Correct. CLI or ASDM, because why we keep CLI? Because let's say already we have a template for site-to-site VPN, we can just do the needful changes on the crypto ACL, the the access list, interesting traffic, PSK, and sometimes those encryption methods or algorithm remains the same. So it is very simple to do via CLI process. If you go with the ASDM, you have to follow all step-by-step on-screen process to reach till the end of the completion.
And for the main mode, the first 4 message, there is no encryption and no authentication.
Yes.
And for AM aggressive mode, for the first 2, there is no authentication and encryption.
Yes.
And the third message should have the authentication.
Yeah, encrypted but unauthenticated in the case of AM.
Okay. But here in main mode, it is being.
In the main mode, it is in the main mode. If you see the two comparison in the main mode, the message 1, 2, 3, 4, it is unencrypted and unauthenticated. And message 5 and message 6 is encrypted but not unauthenticated. After the completion of all 6 messages, it is encrypted and authenticated in the case of MM. Okay. Whereas in the case of aggressive mode, the first 2 messages is unencrypted and unauthenticated. That is, AM1 is unencrypted and unauthenticated. But here it is unencrypted but authenticated at this point. So you can see that circled. And AM3 is encrypted and unauthenticated. So this is encrypted and unauthenticated. Once this is completion, then it is encrypted and authenticated.
Okay. Let's see, during this aggressive mode, can we use host name in negotiation? Because I am working on a site, they have one side dynamic IP and other side static IP, and they are using host names under the keyring, right? They are mentioning, suppose site 1 host name is site1 dot local, site2 is site2 dot local.
You are using what type of VPN? Flex VPN?
No, IPsec. IPsec IPv version 1 aggressive mode.
Okay, you told something key ring, right?
Under the keyring, they are mentioning host name
Yes,
for the
correct.
remote. Yeah.
You have two ways to do here. If you are making key ring, you can either define a host name. Also, if you have a IP addressing, you can go with IP addressing. It is either way that you can go with.
Yeah, but if I use host name, is kind of the host name will go through this packet and it should be matched or to bring up the IP tunnel.
That is right. It should be matched up.
This host name, right?
Yes, correct.
Okay, fine.
Okay, so let's see, what do we have next? Okay, I'll talk about that phase 2, and that was something pending. So you're okay with the AM and QM now. Either the method phase 1 should be up to start with phase 2. Then only the next thing comes up. Okay, so let's see MM. I've shown you the MM versus AM. Okay, regards to phase 2 now. So what do we call them in phase 2? It's called quick mode. And it's straightforward. No multiple 6 message or etc. You can just finish it off in 3 messages. So they are labeled as QM1, QM2, QM3. Okay. So what happens in the phase 2 is there is a security association establishment. There is a key exchange process. And then finally the data transmission. Okay, so let me show you the graph for that. So in the IPsec quick mode, QM mode, 3 messages. Initiator will initiate a request message. Responder will respond with yes or no. And finally, an acknowledgement from the initiator to responder. Once this is done, then the tunnel comes up and the data transmission happens. So what all the things it's going to request? So it's going to have a transform set, which is again part of security association. So transform set, security policy index, nouns, key exchange, traffic selectors, and if there is any NAT address information. So these information, again, you need some encryption, you need authentications, you need the hash value, you need a lifetimer, right? So all those details needed to be pushed as a request, you receive yes or no and a final acknowledge back to that. And once that is done, then you will see the phase 2 is complete message. If you're stuck at phase 2, then as I put down, this is something which you need to check on the both the end. Might be on one side you have MD5 for some reason, and on the other side you have something different. Or on lifetimer you set it 3600, or you have it 54, so and so. So if there is any mismatch, then the phase 2 will not come up. Check the parameters, and you can reinitiate the test packet. Phase 1 will renegotiate, and then it will come to the phase 2, and it should happen much faster than the first process of phase 1. So any doubt with the phase 2, which is straightforward? It's called quick mode. Security association, key exchange, and data transmission.
If we want to
Phase two
take,
is what?
Yeah, go ahead.
if we want to take two, then we can go with two, or by default we will go with this phase 1.
Sorry, come again. I didn't get you.
So simultaneously phase 1 will be done. After that phase 2 will be work.
Correct. Yeah, phase 1 will first occur, then phase 2 will go.
Okay. And phase 1 we usually by default it is a main mode.
Correct. Yeah, main mode. Yes.
Thank you.
And the phase 2 is always quick mode?
Yes, there is only quick mode there.
Oh.
You said one more point yesterday, the aggressive mode is not a secure mode, you said.
Not secured mode, but less secure. I can say that it's a quick way of getting phase 1 up.
Okay.
Okay. And also remember the debugging becomes little complex because of too many things sent across on the message, on just 2-3 messages.
Okay, got it. You said the same point yesterday. Thank you.
Actually, there is two tunnels, right? Phase 1. Phase 1, once the phase 1 tunnel is up, the phase 2 messages are going via phase 1 tunnel, or how it is?
Yes, it is. It needs certain properties of phase 1 to build the phase 2, but phase 2 is within phase 1 only. So it will act as like an overlay. Say, for example, if this is one branch, this is second branch. First one is phase 1, and within this, that phase 2 get created.
So that the headers will be, how will be the headers will go? Like
Headers will be totally different. Okay, what happens with headers is these are UDP bounded, whereas this IPsec is IP bounded. So it will go on. There are two protocols which we will discuss. One is ESP protocol and AH protocol. By default, this is enabled, so IP 50 will be selected. If this is selected, then 51 will be picked up. Okay, so that is one thing. Second thing is there is another mode we have to select within IPsec, whether I need a transport mode or tunnel mode. So by default, tunnel is the most encrypted, authenticated process, and also by default this is enabled. Whereas transport, if you need a quick tunnel build, then you can go with transport. So this is few things which is pending on the phase 2 discussion. Okay, so I just gave you an overview right now. And also remember, the phase 1 happens over on control plane, and phase 2 happens over on data plane. I'll show you that. So if you see this, the diagram might look like this, that IPsec, then IP, first is ICKMP or IK tunnel, then IPsec, and then the data within this. But if you kind of split them up, so phase one occurs over on control plane over UDP 500 450, and phase two occurs on a data plane. So you will decide whether you need a ESP protocol or AH. So this is encapsulation security payload. This is authentication header. So this will be 50 and this will be 51. So we'll come to this in the next class. What are the difference and what is by default enabled. So right now we are discussing more closely the phase one only.
Okay.
Okay, so with the overview of IPsec, now I have one last topic, that is IK version 2. We discussed about IK version 1, the two different modes of it, but IK version 2 was left over. So those people, those guys, those administrator who is preferring to go with the version 2, we know the benefit. It has a inbuilt keep alive dead peer detection. It has inbuilt NAT transversable support. It can support a higher cryptographic suite. That's the advantage of going with this. At the same time, it's much faster also. It do not have that traditional 6 messages. It happens just 2 messages. One is called the SA init, Security Association init, and authenticated. So if you see the graph, so the left hand side I have IK version 2, and right hand side I have a traditional 6 messages of IK version 1. So in the V2, you see that in the SA init request, it is going to send vendor ID, security association, key exchange, and a nouns for that session. And from the response, it is expecting the vendor ID, security association, key exchange, and nouns. So right now it is unencrypted and unauthenticated. Later on, in the next message, which is authenticated request, in this you will see that it's encrypted and unauthenticated. So you would be sending up the IDI, the initiator ID, authentication certificate, or the nouns or the hash value of a PSK, security association, transform set, any NAT config, and security SPI indexing. So all the things in a second packet. So 2 packet basically. One is IKE SA init, so which you can break up into method, like you can call it as initiator and responder, but this is the main message. And then IKE authentication request. This is the second message. Now, if those 2 messages are being dealt positive way, then finally what happens is you will send the final message, but this is where the data is exchanging. So you don't consider this as a third message, because you can say that in a 2 message you are completing the IK version 2, which is nothing but phase 1. Phase 1 comes up if you're going with the IK version 2. The third message is responsible for the actual data transmission within the IPsec tunnel. Okay, so it includes all the security association parameter required for the tunnels to come up. So this is what the difference looks like. So you have 2 message here, and you have 6 message here in a traditional IK version 1 main mode concept. If you compare IKV 2 versus AM, there is still some slight changes. Say, for example, if you go back to this message, okay, this message needs 3 different messages: AM1, AM2, AM3. Whereas there we need only 2 messages: init and request. And this is what is the this is another club diagram to show you what messages got clubbed in the IKv2. But in IKv1, you see 6 messages. So basically 1 and 3 got clubbed into a single message, which was the init. Okay, so 1 and 3 got clubbed into init process. Then the message 6 and the quick message that got clubbed here in the IK authenticated message. Okay, and then you see that after the completion of 2 messages, you will see the phase coming up, and then you will see the final data transmission over on the child essay, create child essay. So these are three messages that we need in IKv2 to bring up the complete tunnel: essay init, IK auth, and the child essay. So any question here with the respective to IK version 2?
Not now, dear. I will go through the topics, and if I come across something, I will ask you tomorrow.
Okay.
Next.
Yeah, sure.
Basically, when the tunneling is going to initiate, it will go with IK1, no?
It depends. Say, for example, if you configured over on the regular config, then it will take V1 only. But if you want to convert into V2, then you can convert to V2 as well. And that is why the Flex VPN was configured. So in a Flex VPN, what happens? It is by default taking up V2 only. In a regular site to site that we've been using it, by default there V1 comes up. And if we want to migrate to V2, we have to delete certain command and add certain command. But if you don't want to fall into that complexity, then Flex VPN is something which is by default put up on a IK version 2 format only.
Okay.
Okay. So this is what I had to cover today. In the next class, I will talk about more from the IPsec now. So we'll talk about ESP, AH. We'll talk about transport and tunnel mode. And then we will go with might be a lab exercise. I will just do a simple exercise initially to build a VPN over on a iOS routers or 2 firewalls, and we will see how the CLIs are prepared. We also need to do it over on ASDM. So be ready for both, that is CLI and ASDM method.
Do it lab only on ASA, or we will use the scenario like one Palo Alto, one ASA? And
No, we are not using Palo Alto in this CCIE. That is in the firewall mastery. In the firewall mastery, yes, we will use 2 different vendors. But this is a pure CCIE, right? Cisco. So only Cisco vendor we will be talking about.
okay, why we are using ASA? Because ASA is, I think it's obsolete. They are no more supporting. Can we go with the firepower FTD?
No, see, right now ASA might be end of life, but in the CCIE exam, still ASAs are used.
So they will ask the question also in the based on ASA only, not in firepower.
No, they are having at least 4 tasks on the ASA. Might be 1 or 2 tasks on the firepower.
Okay.
Okay,
But
you are
for
still
for IPSec tunnel, they may use the ASA or they may use the, if in the exam perspective, I'm asking if they.
see in the exam for site to site, they are using firepower. And for ASA to ASA, they are using any connect scenarios or cluster context, or they can go with the remote access VPNs, SSL VPN. So all that comes under ASA related.
Okay.
Okay, so
But
ASA might be end of life, but from the certification point of view, it is still been used.
why can't we
So-
go with two firepower instead of ASA?
No, we have
For-
to use both the scenario.
Okay,
We have to first deal with ASA, then we have to deal with firepower.
Okay.
But we will be covering router based configuration, right? Yes.
We will be covering router based also, because there are certain VPNs which are router based.
Yeah.
So we will have to do them as well.
Yeah.
Okay, so we will do based on router to router. We will do based on ASA to ASA. We will do based on firepower to firepower. So these are the things that we would be using in the lab.
Fine.
All right, so let's catch up next weekend. Have a nice weekdays ahead. I'll upload the video on the learn .network journey, plus the same reading material. I'll upload it in the G Drive so that you guys can go through some reading stuffs also. Okay.
Thank you.
Yeah. Take care, guys. Have a nice day.
Thank you, Sagar.
Thank you. Cheers, sir.